Hosting and talking, you have to think about two things at the same time. All right, so I'll just start that from the top because we're recording. So once upon a time on an executive's laptop, there was an executive with a house worth a lot of money. But the internet said it wasn't worth much money. A little website called REA predicted that the house price was worth a lot less. This made the executive very interested in changing strategy. And the executive called upon data scientists to make the price predictions more accurate. And software engineers were called upon to make an API for those price predictions. The engineers liked Scala and FP, and the scientists liked Python. And thus, a Python FP code base was born at REA. So let's start talking a bit about what it means to actually do Python FP. I was pretty clueless about programming in Python before this. So this is from my perspective of like what I found surprising going into Python as a functional programmer, and what I found that was useful and what I found that was maybe less useful. Some of it's not technically FP, but it's worth including anyway. I think I see that happen plenty enough at the FP Guild that I'll probably get a pass on that. Yeah, so a sort of chronological order of things I didn't expect going through. The first one was type hints and MyPy. So before we can start doing any of the FP things that make FP what it is, we needed to get types going because Python is, it can appear on the surface to be a dynamic language, but you can make it quite strongly typed by defining types on any of the like functions, function parameters, what a function returns, or in the case of any variable that you have. Now, this relates to something called MyPy as well. MyPy is an external library that you can use in Python, but I will say that the type hints that we put on here are native to Python. So this external library that we use to use for our live AVM API, which is the code base that we're doing in FP Python, we have MyPy and we can run it on that. And it does something called static analysis. So static analysis is a little bit like when you compile code inside Scala, and it tells you a bunch of things. It tells you like, oh, you got this wrong. You tried to give the wrong type here. You didn't give enough parameters to this function, things like that. So static analysis is a little bit like that. And we're sort of able to mimic getting a compile time by using MyPy. And in this example here, you can see this function has asked for a string. We've given it a number. And then MyPy has complained saying that this argument has an incompatible type integer when it was expecting string. So you can then integrate MyPy with your linting and with your build kite build so that if someone tries to do something that's incorrect and is simply not going to work, it already fails the build kite build. You don't have to write extra tests like you would typically in a dynamic language like Ruby in order to get those things working. Cool. So this kind of like emphasizes the principle of catching things before the code is run, which to me personally is a big part of functional programming. The idea is that like everything is so constrained that you get less runtime errors and more errors beforehand. By putting the types on that, you start a whole chain of events that come out from that. So you start encouraging people to avoid side effects because they have a return type, and then you bring in something else. So the next step up from here is adding stuff like optional and union. So we may know from Scala, you have the option type and the either type. Well, these are sort of the equivalent of it. So if I have something in here, we have our same function as before. This requires a string. And instead of handing it that, we hand it nothing at all. So we've got here none, where none is essentially the null value in Python. And if we hand that across to our function, once again, we get a problem with MyPy, saying that this is an incompatible type. It's got none when it was expecting a string. If you introduce something like optional, which is native to Python, you're then able to bring in, make that an optional string, and thus handing none to it does not cause an issue with MyPy. Now, I will point out, these are type hints, not actual classes. So they only help when you run MyPy, a third-party library, on your code to do static analysis. So when you actually run this code, and assuming you don't have MyPy or anything, if I tried to run this code beforehand and I fed into it this none, right? And I fed that into there, this would simply say, like, it wouldn't stop itself. It wouldn't suddenly error and say, I can't run this code. You've just fed a none to something that required a string. It would just keep going through. And then it would either have a runtime error, or it would just say, nothing in there because your variable was none, right? So it's kind of a bit of a drawback in that when you do have Python done in this way, you're really just doing what's simply type hints and not actual classes. So they don't actually help when you run the code. It's not going to actually physically stop you, but it does go to some extent to it. And to be honest, while I was writing this code myself in in this code base, I didn't even notice that it was actually just a type hint and not an actual class. As far as I could tell, like, this was optional, pretty much behaving the same as an option you'd find in as in Scala. But there does come more problems. So let's talk about union a bit more. It's a bit like an either, except union doesn't have to be just an error. Like, how you have in union typically in Scala, you'll have a left and a right. And that left and right will usually represent an error case and a correct case. Union in Python can represent any number of types. So you can have something that'll look a little bit like union, and then you can put correct case 1, correct case 2, and then an error. Put in whatever else you want. It really just represents that whatever you have in there should be an instance of one of these 3 types. But once again, this is a type hint, not an actual class. So you're not able to do something like exhaustive pattern matching on this, and you're not able to run something like a function that just says like .isWrite like you would on an either in Scala. And you can't map over it either. So for example, in Scala, if you had an option, you would be able to go .map, and then it would apply the function if you had a sum instead of a none. In this case, you can't run a map like that. Instead, you have to do this, which is a little bit not ideal. You have to say, for example, if is instance X string, or like in this case, you might want to check, is it like correct case 1? And then when you check that in there, then you can get that from that. Now, I just noticed we've got a comment coming in talking about Python 3.10 will bring structural pattern matching. That is absolutely right. I am literally just about to talk to that. So pattern matching, let's talk about that. We've got it in Python 3.10. Python is sort of heading in this direction where it's allowing more functional things. Where currently Python 3.9.5 is the latest version of Python that you find out of beta and in normal use. Python 3.10 is only in beta. You can use it. We considered using it in PropTrack. We decided using a beta version of a language would probably sting us a bit more than it would benefit us. So you do get this pattern matching, and it's good in quite a few ways. So let's talk about it a bit. Here's an example we've got here where we can match a media object. We can match it on a type here. So we can say, okay, if it's an image and it's got this string variable here, so if the type is equal to JPEG, then you can return something. And then we've got an image here, and you can say, well, all right, if it's of that class and it has a string matching to PNG or GIF in there, then you can use that. And furthermore, you can match it if it were on the video class and say we can't do videos yet. Otherwise, raise an exception and say it can't be handled yet. This pattern matching isn't exhaustive. So it's not able to run like you would in Scala, where you can have an exhaustive pattern match on like a sealed trait, for example, and say, okay, we've got all the versions covered, and anything else in there, you are confident that you've covered everything. You would need some kind of catch-all at the bottom, because your sealed trait perhaps only has 3 possible permutations. Right. So that's a bit about pattern matching. It's coming, but it's not quite there yet. Data classes is another attempt at Python to be a bit more on the functional side. So this was actually introduced in Python 3.7, which was a few versions ago, but there is still a lot of strong signaling that Python's going in this direction with time, which is positive, I guess. So I'll talk a bit about data classes. You have data classes that are in native Python, and they look like this. It says, you add an annotation at the top at data class, and then you can say frozen equals true. And when we say frozen, we mean that it's immutable. So you then add whatever particular bits of data that you want in that data class with the following syntax right underneath. What we're actually doing in Property Insights isn't using the data classes that are native to Python. We're using something called Pydantic, which is a third-party library. So Pydantic has a couple of advantages, in the sense that it's able to do a little bit more validation, tell you a little bit more things, and it works well with our API. So let me explain what I mean by that. We've got a prediction class here, which is 3 things on it: predicted error, predicted value, and target ID. If I attempt to declare some kind of variable and I say prediction, and I call the constructor prediction, and I say predicted error, and I give it some number, then I leave out target ID string. Instantly, I get an error saying you've missed the named argument for target ID for prediction here. So it does some verifying on that, but notice that it didn't say you missed the predicted value, as that was an optional in there. Now, this can be great for APIs because it can return back exactly what you're missing in there. This is an immutable thing. It works much like a data class would in Kotlin or a case class would in Scala. So you've got that going for Python, which is nice, I guess. And it's definitely useful, but it does have the occasional limitation in that you can't make a sort of custom constructor or anything for it, unless you were to start defining, like, I guess, extra functions in a data class. It's not as good as you might find in a case class in Scala. So I guess moving on to the next part, we've got higher order functions in Python. We do not have higher kind of types or anything nice like that, but you do at least have higher order functions. So functions are first class citizens in Python. So functions can be given to other functions, and functions can return functions. What that means is that you're able to do, let me just move this down. What that means is you're able to do your classic functions like map and filter and such that you can do over any old list. You're also able to do partially applied functions. So you're able to do, you'll call it such as partial, and you'll say like my partially applied function. I'll make that much smaller. And then you can call it like this, say equals partial my func. And then say that the original function needed 2 integers. So I could say my func, and it needs 1 of type int and 2 of type int. And we're able to do, a partially applied function there, where the first part is, the first variable is declared as 1. So then you only have to declare the second variable in there. Yeah, but it's not really as like nice as what you did in Scala, because in Scala you're looking at a, when you did this, you would more just call this myfunc thing here, and you would simply call it by just giving it that first variable, and then handing it back. And you might have to do some extra syntax depending on how you've defined your Scala code base to work, but it means that you don't have to do call a whole nother thing like partial here, apply that across anywhere. The syntax is slightly different, and it's not quite as nice because you're just handing in this function and anything else in there. And that actually causes problems when you're like, okay, if you want to hand in 2, can you just, how exactly do you do that? You can use a keyword argument, but then sometimes problems arise with that, and it gets a little bit messy. Yeah, so I think I've kind of covered some of the functional parts of Python and what we can use, but there's even more drawbacks on what we've done so far. The tooling's not so great. So where we use MyPy and we use Pylint, there are occasional times when those things complain about things that don't really mean anything. If you're not using IO with functional Python, you've got to use a lot of try-catch statements. That can get frustrating as your try-catch can expand on very far. A lot of the libraries in the are not really designed for functional use. So if you're expecting, like you can convert a try-catch to either. So you'll get a side effecting function from your library. And when you get that, you then have to wrap that in a try-catch, and then you can return your union of app error or an actual response. And so it feels a little less convenient as you would do in Scala, because you're now writing a huge try-catch for every single library function that you're doing now, and then converting it to a union type, which you then return. There's not particularly straightforward ways to make variables immutable. You do have that frozen in the data class, but yeah. And so there's sort of a bunch of things that are drawbacks that you'll find about it. But I will say, after all of this, the key thing that has done that is often a problem here at REA is that we build something that's semi-functional, but also easy enough for the data scientists that we work with to totally understand, and for other people to hopefully pick up relatively easily compared to a fully functional Scala code base. So we have this advantage of we've had to peel back on a lot of functional concepts in order to sort of get to a stage where we can do a code base that is improved over what it could have been if it was very object oriented or imperative, but does apply some functional concepts. We've also done a little bit of property-based testing. I've sort of left this to the very, very end because it's not totally functional, but it's also, there's a great library called Hypothesis for using property-based testing in Python that I would definitely recommend. And a lot of a sort of final note, a lot of what we've done in here has sort of applied this idea of using a functional core and an imperative shell. This has been mentioned at the functional programming guild like dozens of times, but it's the idea of building a imperative shell that does the sort of IO type operations, where you handle your errors on the outside. So on the inside, you've got a bunch of functions and they always return something. They don't do side effects. They will return something like a union of app error or your response. And then those keep returning up to a higher level where you finally deal with the app error and then do a side effecting function. All right, okay. I think that sort of covers just about everything I have prepared or speedily jotted down to ramble about. I might try and deal with some of the extra comments I'm seeing in here. So data classes and Pydantic do both support constructor time code. Data classes as opposed to init, and Pydantic just expects you to call super.init data. Yeah, so when you do a constructor in Pydantic, I can go up to where I was before, data classes. Yeah, it like, I'm not sure what you're saying here. When you call this, it does, oh, I see what you mean. Yeah, like customizing the constructor. Yeah, absolutely. That's true. I guess you can call super and get a different answer on that. So that's a good point. Anyway, were there any other questions that anyone wants to ask?
I get a question. You know, like when we use I/O, one of the benefits we get is for asynchronous programming. You know, sync, async. I was just wondering. I know that Python has now async from a few versions ago, and I don't know if you guys are using a framework that takes advantage of that or no. Like, you know, the sync away, async away thing.
Yeah, that's a funny one. So look, the answer is no. At the moment, we're not using a framework that does that, but we are looking into one that does that. So we are going to have to introduce a custom framework. Like we're thinking of using a library called HTTPX, and that's going to help us answer some of those questions around how do we run stuff asynchronously. You do have native to Python, of course. You can start doing async functions. So you can async def my function, etc., etc. And then, you know, when you call it, you can be like my response equals wait. You know, my function can do things in there. The problem is, like a lot of things in Python might be natively single threaded or just simply done synchronously. And, you know, for example, if you were to use the request library, which is a native library in Python for making HTTP requests, it's entirely synchronous. And like if you were putting async def or wait or anything in there, it wouldn't really matter. As far as I know, correct me if I'm wrong. Yeah, so like without IO, we pretty much have to rely on another third-party library to try and do asynchronous stuff yet. And we're just not there yet. We're looking into it now, but we're not up to it.
Cool, thanks.
Mitch, you sort of mentioned that you kind of chose to do this in Python because there's like data scientists involved and they like Python. And you guys liked, you know, the devs liked FP. How much involvement do they like still have in the code? And like, I was wondering if they kind of viewed this as like not idiomatic Python that you're writing, or like how's the reception been? And also, has there been many times where you've run into things that you sort of think like, this wouldn't have happened if we wrote it in, another language or like Scala or something else?
Yeah. We think about that like every day. Thinking about like, is this easy to understand? Do they get this? Is it good? Like, so it's an interesting thing. The way it's actually set up, the data scientists have like a bunch of repos that do their models, right? They do their property price predicting models, and then we have an API that sits on top of it. But they have their own APIs inside their little models, and we call to those APIs, get all the information together in one big blob, do some calculation on it, and then send that out. So the overlap is somewhat between we reach into their models sometimes to do things, and that we have other people who work sort of as a cross between a software engineer and a data scientist on what we're doing. We had a retro today on like, is this difficult? And well, the question came up during the retro, sorry, is this difficult? Is it hard? And people were generally okay with it. The vibe was, yeah, this FP is like, there's a bit of FP in here and it's okay. And in fact, we ended up sort of deciding, yeah, we're going to keep on going and take this to a more complex level, where we'll introduce more things. And like, it's basically that there seems to be appetite for this, in that people are happy with the fact that it's not too complex. So it seems to be achieving that goal thus far. And I think if it was in Scala, we would not have achieved that. There would be no way they could touch any of our code, and we would know nothing about Python, so we couldn't touch their code. And we've learned a lot about Python and about how to do Python better along the way, that we've then been able to pass down to some of the work that they've been doing as well, which has been pretty cool.
Yeah, that's awesome.
Was it difficult to, I don't know how did you guys approach this, but I don't know how did you slice the project? How did you do the breakdown? But was it difficult to find a place to do the work on getting the static typing working, the FP libraries? Like how did you convince at the beginning of the project that you would use this for the project?
Yeah. So we had a huge IPR where we sort of decided between Scala and Python, and then we said, well, if it's Python, how are we going to do it? And a big part of that was, well, it needs to be Python done the right way. So we need to involve a lot of particularly these things like the static typing. The short answer to your question is it was pretty damn easy, actually. Adding all of this typing and adding stuff like MyPy and everything, it was really just like, let's add an extra build guide step, specify some things about how you want these libraries to work, and then off you go. You just had to make sure that you had all of the types in there. I think it was definitely like at the very beginning an adjustment for people who were used to writing Python without types to suddenly start writing Python with types. But build kite would basically tell you, if you didn't put a type in there, it would be like, no, not getting merged, like it failed the build, and your PR wouldn't go through. So you'd be stuck there. I think definitely when you do it in that style, it makes it pretty easy for people to keep up with what you're doing. Yeah, like it's, so yeah, like to answer your question, we were pretty much only going to do Python if we added all of this extra functionality and all of these extra like libraries and stuff in the first place, because otherwise we would have just done Scala and argued like, no, this will, like, we prefer it to be constrained to some extent. So this was kind of the meeting halfway. where they convince the Scala people to do Python by saying, okay, let's put in all these extra things. Yeah.
Cool. Thanks.
Just on that, Mitch, I know in TypeScript there's kind of like a, I don't know, a pain point where if some library that you're using didn't supply types, you kind of end up having to do them all yourself or use like the escape hatch of any all over the place. Did you run into anything similar, like trying to type Python?
I can't think of any case where trying to supply a type would cause a problem like that. So I should probably clarify. These are like, the thing is they're type hints as opposed to an actual type that you're putting in here. So it's more of a hint to something like MyPy that something's going on. So you can get pretty like loose with what you really put on there. Worst comes to worst, you can always put a type of any in there, but we haven't had to do that thus far. I know I've seen a lot of TypeScript where people are just like any, and that like burns me up inside. But we haven't quite had to do that because it's it seems pretty flexible. Any type that exists, you're able to sort of put on there. Like, am I sort of understanding and answering the question correctly, or is that?
Yeah, like I guess like, you've probably got functions that accept some of these custom data class things that you mentioned before but like, what's the type for that? Is it just, if you've got my data class, is that the type that you'd attach to the argument, or is it just like object or something?
Yeah, absolutely. So you don't have to do object or anything like that. You can literally just do my data class, and that will just work. You don't have to, do anything generic like object or any or anything to try and make it work. Thus far, I have not seen an example where attempting to use a custom class of some kind has caused that error.
Just in what Nick was saying before, if I understood correctly, because I think I had that problem with Ruby before, is like if you have a library, for example, let's say that you have a client for doing an HTTP call. If that client is not typed, it doesn't return types, you do the call, let's say it returns 200, but it doesn't say that it's an integer, your compiler just can't give you any guarantee and you lose the whole benefit in that piece of code that is using the client. I don't know if you
right. So say you have like a response, and it comes from your client post thing, right?
Yeah.
And then what happens after that is you're like, what type is response? So if this was inside some kind of function, and I've written out a function, my func, and then I've declared that function as returning of a type response. So this client.post thing here, there's two ways this can go, right? Now, the most common way I've seen this happen is that client.post thing returns a class of some kind. Usually it returns some kind of class. And all I would do is I would declare the function with response, and then I would do something like, import from my clients. So I'd be like, from my client, import like models.response. And from that, I would get the response class. As long as I had that imported, it's then able to recognize that that is a response class. Under the hood, it's recognizing that this is a response class with the, like, it's putting an automatic type hint on there. And then it can see that, like, when this function returns, so if I say in here, return response, it's going to check and it's going to be like, sorry, that's a lowercase response. I'm returning the variable. If I say return response, it's then going to check and say, all right, was that of type response? Is that a response object? And it, like, MyPy is able to correctly check that.
So you're saying it doesn't depend on if the library has implemented these type annotations. It just needs to return a class, and that's just gonna work. Is
Yeah,
that right?
absolutely.
Oh, that's
It
cool.
doesn't depend that the library has implemented that type annotation. The alternative, if something's being really weird, is to just do this. And you just add the type hint yourself. And then that will force it to recognize that it's that type.
Which is kind of like casting it though. Like it could actually be not, could it actually be not that type? Like if it can't sort of figure out that what client.post returns, and you just say, like, I'm telling you responses of class response. Is there any like guarantees past that point, or are you kind of just like crossing your fingers that you said it's what it is?
Good question. I think if this is not type annotated, so if client.post here is not type annotated, then it's a crossing your fingers deal. If it is type annotated, then MyPy will be able to tell, and it'll tell you at the beginning. So it depends on the type annotation of that library, whether it has that or not, I believe. I'm not 100% sure about that. Because thus far, I've never actually seen it mess up in terms of not being able to get the type from any library that you're sort of asking for there. But I guess in theory that could happen. I just haven't seen it happen in practice.
Yeah, I think it sounds like it's kind of a different thing to TypeScript and JavaScript, because something about like knowing, you know, the class that you're talking about, it's in native Python. It's not like in the TypeScript level above JavaScript. So it sounds like it kind of would be a bit smoother than that problem I mentioned at the start.
But even if you know the class, I think because if it doesn't have types in the library, it means that it could return none, right? And you are not capturing that if you try to annotate that as response, right? Like even if you know that it's returning that class, that doesn't guarantee that it's not going to be none. And a type annotation will capture that.
Yeah, so I guess, like I said before, it kind of comes down to whether it has a type annotation, as far as I know. If it does, then you're fine. If it doesn't, then I guess you could have any problem with that, not returning how you expect it to return.
Hey Mitch, I've been playing with Ruby 3 and types, and I found that if I have like a double, and I put double in as a even I use double instance, when I call a function with that stub double instance, it complains that it's not the right type. So do you find a similar experience with Python?
About complaining it's not a right type when you do have the right type, like
when you're using stub or something like that, or what during unit testing?
The short answer is no. I haven't seen any example like that with the typing messing up in that way. It seems to have been pretty robust so far. Yeah, that's the gist of it, I guess. If you you wouldn't have, any type that you've added in there is of course like a type hint and not an actual type. So when you run the test, if I'm running the test and I haven't run MyPy or anything, it's pretty much ignoring type hints. So if I've told it something like, you're meant to put a double in here, and then I put a double in there, it's sort of just said to itself, like, I actually don't care that you told me that a double should be in here. When it's running the code, so in your tests, it's only when you're running something like MyPy that checks the types that it actually picks up something like that. So it's only picked up when you do static analysis of your code, as opposed to when you're actually running the code. And it's like both a good thing and a flaw, in the sense that when things go wrong and you have an example like that double, it's not going to like bring everything to a screeching halt, but it also means that like your actual code, when it is actually run, is not checking anything. It's only checking it when MyPy is run, which is usually just run before you commit the code. Alrighty. I think seem to have exhausted the list of questions. So I'll probably wrap it up here. I'll post some links in the channel about where you can find out a bit more about doing Python and FP and how we actually did it. So you can explore it a bit more. It is flawed, but it is also got some good things about it. So it's a mixed bag, that's for sure. All right. Yeah, let's wrap it up. Thanks, everybody.
Thanks,
Thank you, Mitch. Great job.
Thank you.
Thanks.
Bye.
Thanks, Mitch.
Thanks.